I'm from Thales Alenia Space, and we deliver space infrastructure such as satellite constellations and space missions. Our team in the UK is a specialist in satellite propulsion, which we manufacture in a space factory in Belfast, Northern Ireland, and we do our design work in the Harwell Space Cluster near Oxford. Now, a satellite's journey begins with a rocket launch to a low orbit, and after separation, it has to maneuver under its own power for the rest of its working life, and that's the task of satellite propulsion. So propulsion is designed to meet the specific needs of operators' missions, and if it fails at any point, that mission is severely jeopardized or may even be over. So the designability and the reliability needed makes propulsion a critical technology to master in space companies and in spacefaring countries. So ideally, a propulsion system is optimized for a very predictable working life. So, for example, most modern satellites typically use very, very efficient electric propulsion, and that's half the size of tanks and allowed payloads to double in size, which has been very good news for SATCOM competitiveness and for users. But what we find is that the Earth orbits are changing and they're becoming more congested and more contested, and the life of satellites is becoming less predictable. So some operators are now asking for more agile satellites, which are able to maneuver quickly and flexibly. Now, every time a satellite maneuvers, it consumes some of its propellant. So one of the toughest decisions we make is what kind of propellant to use and how much to take with us. And so one of the most exciting developments is refuelability on orbit, because a midlife refuel enables tremendous flexibility without needing to take an enormous tank in the first place. And Thales Alenia Space in the UK is one of several companies developing refueling technology. We have designed already and manufactured already and exported 8 Spacebus Neo propulsion modules. So this product is the mainstay of our SATCOM business, and it's trusted by commercial and defence operators globally. And this really demonstrates the trust placed in our team to deliver propulsion, a critical space technology. So military satellites are really, I think, the first compelling case to do midlife refueling, and it depends on some key technology building blocks that will be developed, are being developed now and will come to maturity in the next 5 years. So satellites first need to be equipped to support rendezvousing and docking, the coupling of fuel lines and additional sort of plumbing and monitoring to allow tanks to be refilled safely without leaks or risks of explosions. And secondly, the servicing satellites need to be able to safely, reliably rendezvous and dock, and either bring fuel with them or get it from a nearby station. So these are some of the most exciting technology developments going on right now.